Good morning all. Today I am going to present my paper Modeling Cognitive Scores for Alzheimer's Disease Progression Prediction using Longitudinal MRI. This is the outline of the presentation. Introduction, motivation, objectives, literature review, proposed design, result, conclusion, future work and references. Alzheimer's disease is a neurodegenerative disorder characterized by progressive impairment of cognitive functions. The cognitive function include memory, speech, ability to learn, etc. As a person gets older, there will be decline in the cognitive function of an individual. So it is very difficult to distinguish between normal aging and an AD patient. Clinicians make use of neuroimaging modalities such as magnetic resonance imaging (MRI) to understand the structural and functional changes in the brain. Along with the neuroimaging data, cognitive scores are also used to diagnose the disease. The cognitive scores such as Mini Mental State Examination and Alzheimer's Disease Assessment Score 13 evaluates the cognitive ability. Studies have found that there is a high correlation between cognitive measures and structural changes in MRI. So the regression models can be trained to find the association between cognitive measure and the structural changes in MRI for AD detection. The motivation of this work is that early detection of the disease helps to start the treatment plan in the early stage itself and improve the quality of the life of the patient. The cognitive score measures the cognitive decline and help in the AD progression detection. Age, education, cultural and socio-economic background can cause a considerable bias in the score. Some individual who is visually challenged or hearing impaired will score less for cognitive test even they don't have cognitive decline, which create a bias. Another reason for biased test result is that patients undertaking cognitive tests multiple times tend to learn them and score well at follow-up session. So the objective of this work is to train regression models to accurately estimate scores such as Mini Mental State Examination, MMSE and Alzheimer's Disease Assessment Score 13, ADASA 13 from longitudinal MRI data for AD progression detection. The second objective of this paper is to identify the most important brain regions that are affected by AD. This is the literature review conducted as part of this work, and these are some of the paper that is being considered. The first paper make use of lasso regression model as a regularization technique. It provides a very good accurate prediction of this disease, and it is very good in feature selection. But the limitation of this work is that it randomly selects one variable among two or more collinear variables. The second paper make use of the random forest algorithm for classification and regression. And the advantage of this paper is that it provides very high accuracy and it scales very well. But the limitation of this paper is that it cannot extrapolate. The third paper made use of elastic thread regularized logistic regression model for feature selection and diagnostic accuracy. The data obtained for this study is from resting state functional magnetic resonance imaging. And the advantage of method is that it does not easily eliminate the high collinearity coefficient. The limitation is that the PET and CFS based biomarker validation are not available in majority of the cases. The fourth paper made use of the support vector machine and it is trained with MRI features and ADSS cognitive score to distinguish between AD and healthy control subjects. The advantage of this paper is that ADSA cognitive score test results significantly improved performance measured obtained by the classifier. And the limitation of this paper is that the cognitive test result may be biased against people with low education or with visually or hearing impaired. The sixth paper examined the evolution of the cognitive side effect of ECT in large group of patients with late life depression. And it is most widely used, MMSE is the most widely used cognitive score. And most of the available research on cognitive effect of ECT has relies on the screening code tool. The limitation of this is that cognitive tests may be biased against people with low education or with visually or hearing impaired. The last paper made use of heterogeneous autoregressive models, HAR models, and rigid regression methods to predict the gold future price in China. In this paper, the rigid regression model has found to be superior than the heterogeneous autoregressive model. But the limitation of this paper is that the rigid model is not good for feature reduction. This is the architecture of the proposed method, and here we are having a module for data set. That is, the data set that is used is from Alzheimer's disease neuroimaging initiative database, and the biomarkers such as cognitive test, magnetic resonance imaging region of interest, PET measures, DTI ROA measures, CFS biomarkers, and risk factors are taken from the data set. The data set is a raw data set, and we have to pre-process this data set. And for pre-processing the data set, the longitudinal data at the baseline 6, 12 and 24 month is selected. 356 subjects ID are selected, out of which 68 are AD, 124 are CN, and 18 are early mild cognitive impairment stage, and 146 are from the late mild cognitive impairment stage. The pre-processing is done by removing the empty columns and cell with NaN-4 values. Then the missing values are filled with the random forest algorithm. After the missing values are filled with the field, min-max normalization is applied on the imputed data set. From the pre-processed data set, the structural MRI features are selected. The selected feature set has 318 structural MRI features. These 318 features are from the ROA volume, ROA cortical thickness, and ROA surface area. ROA is the region of interest, which are of various brain regions. The variables to be predicted are MMSE score and ADAC-13, where MMSE measures the cognitive impairment and ADAC-13 assesses the severity of cognitive symptom of AD. Hyperparameter is the input to the regression model, and it cannot be directly learned from the regular training process. The hyperparameter values are randomly selected before the actual training process. This parameter expresses the complexity of the model and how fast it should be learned. And various tuning process has been also been done to tune the hyperparameter values. The regression models used in this study are a rigid, lasso, and elastic net model. In rigid model, the cos function is given as 1/2 of y minus x beta plus lambda of beta, where y is the actual cognitive score of the subject, x is the training data, and beta is the weight matrix, and lambda is the regularization parameter. The penalty term is the absolute sum of the square of the coefficient. And in the lasso model, the penalty term is the absolute sum of the coefficient, and it performs feature selection. And the cos function for the lasso model is given as in the equation, where y is the cognitive score of the subject, x is the training data, and beta is the weight matrix, and lambda is the regularization parameter. The elastic net model combines both lasso and rigid model. The cos function of the elastic net model is also given, where here the y is the actual cognitive scores, beta is the weight matrix, lambda is the regularization parameter, and alpha is the mixing parameters, and n is the number of data samples. And here we are having the optimizer. The optimization algorithm that is used is a coordinate descent, which minimizes along each coordinate direction in a successive way to find the minimum of the function. And this is done iteratively to train the regression models. And based on this, the prediction is being done. For the cognitive score prediction is estimated using regression model by following a linear predictive function. Y predict is equal to x star b plus intercept, where x represent the MRI features selected for a particular time point, y predict represent the corresponding predictive cognitive scores at that time point, and beta represent the coefficient metrics, and intercept represent the bias. So this is the design of the system, and the biomarkers are also identified. For the result, the metrics that is used to evaluate the performance are mean absolute error, root mean square, and Pearson correlation coefficient. The mean absolute error of the various models, rigid, lasso, and elastic met, is being compared for baseline 6th and the 12th month. The MMSE prediction of the first table shows the MMSE prediction value, and it is found that the elastic net model is having a better prediction accuracy. That is, it is having a low error compared to rigid and lasso model. For ADSA 13 also, the elastic net model is having less error compared to the rigid and lasso. So we can say that the elastic net model is having a better prediction accuracy compared to rigid and lasso model. This is a comparison model for root mean square error. The root mean square of error of rigid, lasso, and elastic net model are obtained from the cost function. When we are comparing these three models for baseline 6th and the 12th month data, the MMSE score prediction is better for elastic net model. And similarly for ADSA score also, ADSA 13 also, the elastic net model outperformed the rigid and lasso at the baseline 6th and the 12th month. This is a comparison of the Pearson correlation coefficient of rigid, lasso, and elastic net model. Here also the elastic net model outperformed rigid and lasso for both MMSE prediction and ADSA 13 prediction. This diagram shows the scatter plot of actual and predicted value for the baseline data. By using the predicted this prediction, the interline predictive function, this scatter plot is done, and it is found that the more data is closer to the actual and the predicted value is more closer to the line in the case of elastic net model. So we can conclude that the elastic net model is having a better prediction accuracy than the other two models. Similarly, when you are looking into the scatter plot diagram of rigid model, lasso, and elastic net model, the data are more closer to that line in the case of elastic net model. So ADSA 13 elastic net model is better than the other models. And this is for the scatter plot of the actual and predicted value for the 6th month data for MMSE score. Here also elastic net model is having a better correlation with the actual and the estimated MMSE. This is for the ADSA 13 prediction, and here also the correlation of elastic net model outperformed the rigid and the lasso. This is a scatter plot for the actual and predicted value of the 12th month data. For the 12th month data also, the correlation between the actual and the estimated is plotted, and elastic net model is having better performance for MMSE prediction. And for ADSA 13 also, elastic net model is better as the data is more clustered towards the line in the case of elastic net model. These are some of the features that showed high value when we have predicted the MMSE score. Based upon the baseline data, the features that are selected are cortical thickness average of left entorhinal, volume of left hippocampus, cortical thickness average of left inferior temporal, cortical thickness of average of right endothelial, volume of right endothelial, volume of left inferior temporal. These are the features that are selected for the baseline data. Similarly, for the 6 month data also, another set of values are also selected, which showed high prediction accuracy. So these are the features that are selected for the MMSE prediction for baseline 6th and the 12th month data. These are the features selected for ADSA 13 prediction and their corresponding weight for baseline 6th month and the 12th month data. And based upon the 6th, 12th and the baseline 6th and the 12th month, the 24th month prediction is being done for MMSE and ADSA 13. And the error result of mean absolute error and root mean square error and correlation coefficient is given for this. And the top 10 brain regions that are important for cognitive score prediction is being selected. Among this, Three of the brain regions, top three regions are being studied further to understand the correlation of ROA with the this MMSE score. The correlation of left hippocampus with the baseline 6th and the 12th month and the left inferior temporal correlation with the MMSE score of baseline 6th and the 12th, and the right endothelial baseline 6th and the 12th month is also studied. Similarly, the correlation of the ROA with ADASA 13. The ROAs are left hippocampus, left inferior and right endothelial are studied for ADASA for baseline 6th and the 12th month. Then it showed that it is having a very high correlation compared to other ROA. It showed a very high correlation. The conclusion is that the study trains regression models such as rigid lasso and elastic net to estimate cognitive scores from structural MRI. Elastic net model outperformed both rigid and lasso. The elastic net model predicts MMSE score of baseline 6th and 12th month data with MAE of 0.164, 0.116 and 0.105 respectively. Elastic net model predicts ADSA score 13 of baseline 6th and 12th month data with MAE of 0.113, 0.121 and 0.118 respectively. Elastic net model uses predicted cognitive score of baseline 6-12 month to estimate 24-month MMSE and ADSA score with MA of say 0.099 and 0.118 respectively. The features selected by elastic net model are found to be highly correlated with the cognitive scores. The future work include we can try out with other regression model and with other optimization technique. And we can consider other cognitive scores other than MMSE and ADSA score for future prediction of Alzheimer's disease. These are the reference that is used. Some of the reference that has been used. Thank you.